Right. Last lecture, right? So we did studied about the continuous test, as I guess, yes, right? So initially we test the continuity at a single point. So for that, we uh, some functionalities. So first one is it should be defined at a point. Then uh, the limits from coming from the right end and the limit coming from the left end. These uh, should be defined, and uh, then those are need to equal to the defined value at that point. So when those are okay, then we can say this function at that point c, so it is continuous. So that's the way we did. Then we expand this test to a range, right? So for the range, first we generally need to show uh, using the common value represent the all the range. Uh, then uh, we need to show it if it is continuous. Then we need to check the endpoint. For endpoint, we don't have left point for this left margin, and we don't have right function from the right end. So only need to check whether it is it has a limit coming from the right end, and it should be equal to this defined value. And we need to check the limits coming from the left end, and it should be equal to defined value. So those three are okay. Then we can say uh, this function uh, continuous throughout this range, including the endpoint. If not, we can write as this way at the endpoint, this function is not continuous, but within the range, this one is continuous. So we have to use the technique to show the functions throughout the range or at a point, like if we need to check the continuity. Right. Today, this start at the beginning, we have to learn another property, right? So still, then we organize that continuity test for the for these combined functions as well as multiplication and the uh, divisions for f plus g, f minus g, f dot g, and f over g. So no matter in these cases, both every functions for those combinations, they are continuous. In this case, f over g also continuous, but there may be points that function does not continuous because we have to see the denominator, because g, if the g going to 0 means that at that point these functions f over g functions may not continuous, so we have to check. So most probably if you have a problem to identify the discontinuities, that problem most probably should be f over g case, right? Then today at the beginning we are going to prove or learn the another property. So you need to keep this one also in mind. So we are going to the compositions. So uh, composition of functions, then how to find the limits.
Recording in progress.
Right. So if let's define this. These are the requirements, right? We have a function called g, right? Gx, and when the x goes to c, x approach to c, then assume that this functions shows a value called L, right? This is a general one. So G, when limit of G, when x approach C, it goes to L, right? And then there is another function called F, right? And F is continuous. Is continuous at L, right? Now you know F is continuous at L means you can write down lots of things. What are the limit of F? Let's say this is not x as y. Let's take as a y. Then when y goes to L, you can write this one should be equal to F L like that, because limits and the defined value should be equal when F is continuous. So if this one is happen, we can say F is continuous at L. If someone said F is continuous at L, then you can write the inverse. That means these are okay. So then, right, when both are happen, then we can write down as like this. Now we are going to the composition. Limit of x approach to c f gx. So functions are the composition. Right? Okay. Then we have to think about. We learned a little bit compositions earlier, right? At the functions, when we talk about the functions, you know that how we calculate the compositions. First, we apply the value for the inner functions. Then we have another one. Then we apply that value into the outside function, and we find out the value. So this I hope you can remember. So anyhow, so this is the composition. So at the theory, right? So you can say, you can see this one, the gx function called g, it shows a value L when x approach to c, right? And that value also for considering about at this point, f is continuous at L, right? In here, if this one is happen, right, when both are happen, so you can write down this, right? What is that? I'll write FL. FL means what? Here, because F is continuous now. So at the L, you can write this one. So in here, you can say a little bit. So gx in a function is gx. So when limit of x approach to c means, first you have to consider the gx function. So gx also well defined because it has a limit. When x approach to c, it shows L. So what's happening there? So instead of gx function, right? I can write down here L, no matter, right? So if you see this one, FL, again you can write down another way. What is that? FL means, again, L is equal to this part. Limit of Gx when x approach to C. Right? L you can write down as this way because L is equal to this one. Right? So finally, we have this kind of, but here limit is outside and Gx is there. So instead of finding this one, right, you can find the limits as this way. What? So limit can separate from the bracket. So limit is goes to the inner function. So if you have a function at the conversion modes, you can directly apply this property. So this is a property. No need to prove at that point. You have to memorize. Right? If you see these kind of functions, compositions, and you have to find the limit. So if you don't know the conversion, this part, you cannot solve this. Instead of finding this one, if you know the property, then you can simply do this one. So first find the limit here, then you can find the value of F. First you find the limit of G, then you find the value of L. So you can things if you know this theory, right? For example, before go to the example, write down this one also. This is the major one. That means the idea of we can separate limits by composition is the idea. Right? Is the idea. We can separate the limit. So limit is there. We put the limits at the inside. Right? So you can apply it directly. Right? Let's say this kind of example when x approach to 4, we have to find the limit of 10 minus 3x squared. Right? So by looking this function, you can see the modulus is there, and inner you have a polynomial. So modulus, that means this kind of one. So I will write down not x. I will write down y. So inside y, it is a polynomial. So this has two functions, right? This is one function. This is one function. So we see some composition. So if we need to find the limits of this kind of problem, so we can apply this property, right? Instead, so if we don't know, we are stuck here, but we know the property, then we can do this one. We can separate the limits and find out the value. If we write down this one as like this way, it is very easy to now solve because now this is polynomial. We know every polynomial how to find out the limits. So just apply the value at that point because those are continuous. Each and every polynomials are continuous. So no matter, we can just apply the value to find out the limits. So 10 minus 3 times 4 square means 16. 16 times 3. Find out the value. This is the value. Here, 16 times 3 means 48. Then this one is equal to negative 38. But we have modulus at the outside, so answer is positive 38. Not the negative 38 because modulus should be there. So therefore, the answer is positive 38. For solution for the inside, answer for the inside is negative 38. So thing is, instead of finding this kind of way, so it is very difficult to handle this case. But if we use this property, right, because those are equal, so we can separate the limit and find the value. So it is very easy. Okay. So you have these things. If two functions are continuous everywhere, they are composition. Their composition is continuous everywhere. So if we have two functions, if we know these functions are continuous at each and every point, so we can hold everywhere, then any composition between these two functions, right? So their composition, that means it may be f gx or g fx, right? So these are continuous everywhere. So this one we have to keep in mind, right? And next thing, if f is continuous on its domain, right? F is continuous on its domain, right? Okay, that means what is domain? So there may be a domain and we have functions. Then if we have put these values in the domain, then we have output called what? Range. This is domain. Right? So f is continuous on its domain, right? That means domain, each and every value that we consider. Then f inverse, so inverse function. We did not discuss about this function, right? But now we can learn it. F inverse will also be the continuous on its respective domain. Right? Respective domain means what? The range of f. Right? Okay. First, we need to learn what is f inverse or inverse function of f. So, if we have a domain, we can put that domain into this function called f. Then we have a range. When we input these values, we have another sets of outputs. So we call all the outputs as this range. Right? So f inverse means then reverse, right? What's happening there? So for to f inverse function, domain is the range of the previous function. So you can see direction is changed. Now for this f inverse, I will change color. Domain is this one, and range is this. Right? So these functions are two different. For this function, if we apply the values at this part, then it will give us this value. For a inverse function, if we apply this value, then it will give us this value. For the respectives, that means for this f function, domain is this one and range is this one. For f inverse, domain is this one and range is this one. So you can see the range of the f is the domain of f inverse. Right? So, for example, let's take first you have to know how to find the inverse function. No? So let's take a function called fx. This is x cube, right? So this is the function. So if you need to find the f inverse of x, so how to do this? You didn't learn earlier, right? You learn it now, right? At the functions, we did not go through this inverse functions, so you can learn it here. So fx equal x cube. So let's take for the fx, let's take as y equal x cube. It is very easy right now. So then what you can do at this point, you can solve for this for x, right? So how to do that? How to find the inverse function? Right? At this moment, right? So you have a letter called y that is belongs to f, and letter called x, so that is the independent variable. So this is the dependent variable. We change these letters, right? We put x there and y there. Then we have this function. Now you can solve this for y. Y equal square root, not the square root, cube root of x. Right? So this is the new function. So at this moment, actually, right, this y represent f inverse x. F inverse x. Right? This is the way of finding the inverse function. So I saw at the very first lesson when I go through take the attendance, some student sent to the chat box at that moment. I didn't see that message how to find he or she asks how to find the inverse function. So now I hope you have the answer for it. Right. First, take the original function. Then, for the fx, you can write down the y. It is very easy for you. Then, change the letter y and x. Then, solve the function for y. Right. Then, at that moment, y represents the inverse function. Right. So, that is the way of finding the inverse function. Right. Let's do little bit. Let's apply some value. So, this is the fx. So, you have a function fx. You have a function f inverse x. X means x cube. F inverse x means cube x root. So you have a domain and the range for f. Let's apply a value. Very simple one. Let's take 2. Then if you apply number 2 for this function, then it have a result of 2 to the power 3. That means 4, 8. Right? 8 is there. Right. Now, again, see, for the inverse function, range is this one, domain is there. So if you again input that this value to inverse function, it should be give the same value what we have inside. For f, right? So apply 8 here, cube root of 8, right? So here you can write instead of this place, this is the original way of writing the cube root, right? That means 2 to the power 3 times here. Then answer is 2. Okay. You again come back to the initial value. So this is the idea of inverse function, right? So here this statement said what I have explained it here. If f is continuous on its domain, that its domain means this one, right? Then f inverse will also be continuous. F inverse, it's also be continuous on its respective domain. Its respective domains means what? The range of f. This is the range of f. So that domain is this set is the domain of f inverse. So anyhow, the same values are there, and each and every value, it has some value, and this statement says f inverse should be continuous, right? In its respective domain. So whatever the represent is, we know this one, but mathematically it's this statement as a statement, right? Okay, these are some extra part. So today, then we have to learn some important theorem, but not these things are very simple one, but we are going to learn it in the mathematical environment. That's the difference in the calculus, right? Everything what we have, it is very well-known part. We can feel it, but we have to prove it using the mathematically. So that is the things we are learning here, but we are learning very simple cases, right? So intermediate value theorem, right? Intermediate value theorem. This is the thing now we are going to study, right? It's row function. Let's define 2 points called A and B for the respective values. So this is the function called F, right? So how to find the y value for this point? The function is F, right? So this one should be what? F, B, or A? If you need to find the y value, just apply A for this function. Then value is F A. So if you need to find the y value at this B point B, that means F B. Right? So we have these values, right? Right. So intermediate value, let's define this one, intermediate value, right? So the name already interpret the things happening or learn, we are going to learn inside. Right? So first I write this, then let's discuss. So F is continuous on the range AB. Then let's define another value at this point called K. Say K is between Fx and Fa and Fb. Right? That means K within the range of Fa and Fb. Right? Then there is at least one number called let's say C, right? Where C is between A and B. And this is equal K. So what this one represent? So this is the intermediate value theorem, right? So there is a function, and first thing is within this considering range, this function is continuous. So each and every point is continuous. So we can find a value within this range. There is no any asymptote or holes within this range because this one is well defined. This is F is continuous on this range, right? Then K is a value, right, between Fa and Fb. K is a value within Fa and Fb. Okay. Then what it said, there is at least one number called C is between A and B. So if we define a K value in between here within this Fa and Fb, then the value called C, right? Is C we are coming from the here. So the value of x that gives the k, right? So this C should be within A and B. So this is well known statement. You know this one, but now mathematically said as like this, and we call this intermediate value theorem. But here you have some problem. There is at least one number. They call at least, but there should be more. Right? That is why this term that be right. Because some functions, you know that, let's say very simple functions, the x squared functions, like this way. So you know that if you take a range or a b as like this way, then see, if you consider some k value at this point, you have two a dash and b dash values in between this range. So number is not one. Yeah, in this example, it has two x values or two c values. So that is why we write down at least one should be there, but in according to the case, there should be more x values, right? Right. So this is the intermediate value theorem. Right? Okay, now we are going to do something using this intermediate value theorem. So this theorem said, if you consider within this y values, you consider some values in between these y values, there should be a x value in between the considering range. Right? This theorem said like that. So let's clear this one. Now we are going to do something using this intermediate value theorem. So let's we are going to define a function as like I will take the range a and b like this. Now my f is there. FB is there. Okay. Right. Now I'm defining this one. If FA and FB, right, have different signs, have different signs. Sign means positive or negative, right? Different sign. There must be at least one root on this range. Okay, what this one say? First, you have to understand what is root. You know that in earlier at the grade 9, grade 8 also you find out the root of the function. If the function is give like this way, let's take x squared x plus let's change as plus 6. Right. Let's check this one. So this is the function you have. So if you give this one at the grade 8 or grade 9, what you have, yeah, what you have it, what you did there. So you equal to this one here and find the factors of this x plus 2, x plus 3, like this way. Then you individually assign equal to these factors to the 0 plus 3. Then you find out the value -2, then -3. Then you write the roots of this function is x equal to x equal -3. So you did at your level, right? Level. So what is the root? At that time, sometimes you don't know what is the root. Root means what? When you apply a value, x value, to this function, it gives 0. So this is the 0 level, y equals 0 line, right? If functions goes to 0 means that position is a root. That means if we apply this value called, let's say, xc to this function, right? Then fc should be 0. So this theory you are using at this point. That is why you equal to this function to 0 and find out the roots. Right? Sometimes at that moment you don't know what is happening there. You do the process. Right? Now you can learn it. Right? Root means what? At that point, if c is root, then fc should be 0. Okay, now you know the idea about the root. Okay, now our case is if FA and FB have different signs, that means within this range, if FA, let's take FA is positive and FB is negative, then what happened to the functions? That function should cross the y equals 0 line. That is why we have a different sign. That might be this way, or that might be this way. This may be FA, maybe FB. Right? However, there is a point that cross the y equals 0 line because the sign of FA and FB, it has a different sign. Right? Okay, then what we can say, there must be at least one root because cross the line means there should be an intersection, right? So intersection means the function intersect with the y equals 0 means that is a root. That point is a root. So that is why we say at least one root should be there. But it might be more. Why? Let's take again the same way of the function. In here, if you consider a is there, Let's take another one. This kind of, you consider A as like this and B at this point, on this point. Let's take B is there. Then A has a negative sign, FA has a negative sign, FB has a positive sign. Then you can see there are 3 points that gives that cross the or intersect the y equals 0 line. That means those are roots. There are 3 roots for this function, right? So this may be increased, but we can say must be at least 1 root. So there is, we can write down as this way. So, using the intermediate value theorem, we discuss about the root of the function by considering the y values of the function. If we check the sign, then we can say this one should have roots. That's the things what we have learned. Okay. So these are some extra points, right? No need to consider things, but think you have to write down a computer program to find out the roots. Right? So how you approach that one? Using MATLAB or any other Python program. So I think you have to write a program to find out the roots. So I will give you a function name. This is the function x cube x minus 1. This is the function. But you have to find out the roots. So how will you approach to write down the program? You should have a mathematical knowledge to write down this kind of program. So you can use that concept, what you have learned earlier, using the intermediate value theorem to find out a way to say about roots. Right? So let's take again, this function might be like this way. Right? So what we have to do, first you have to identify values that give the different signs for y values. Right? So first you have to do it. Let's take point. Let's apply 0.1 here. Then what happened? 1. Then this is negative, right? This is negative. Then if we apply 2 here, what happened? 2 power 2 power 2, that means 8. Negative 2 is 5. So this is a positive value. First we have to identify the 2 values, right? And that is edge of your inputs, right? So this is negative, this is positive. Right now you can start the program. How to do? What you have to do? In mathematical way of handling this thing is like this. You can apply the values. First you apply 1.1, 1.2, 1.3, 1.4, 1.5, like that, 1.6, like that way, up to 2. Then you check the y value, right? Sign of the y. Sometimes you may have here negative, 1.3. This one again negative, here 1.4. Here you can see the sign, positive sign. So sign is changed. For this, you have positive. Right? So you first capture these 2 points. Right? Negative, positive. Then you can take this value again and do the next iteration. How to do? Then your start point is what? Something 1.31. Then 1.32, 1.33, like that. You can implement this up to 1.40. And again, check the signs. This might be negative, this might be negative, this might be negative. This is 1.34. I don't know whether this one negative or positive. Let's check this as positive. Then if here you can say if you are considering decimal point of the root, it is 2 decimal point, then you can say 1.33 or 1.34 is the root. If you need to consider something more with higher, that means minimizing the error, then you can do the again next iteration, that is starting from 1.331, like that. You can write down the program to iterate this way. So little by little, what happened? You approaching the points by looking the sign, and finally you have a precise or very exact value to find the roots of the function. So numerically or computationally, you can write down a program like this. So mathematically, you learn the same thing. That is why I explained it. Okay, next we have to learn again some fundamental of the calculus, right? Now we are going to learn to find slope of a curve and called velocity and rate of change. Now we are going to learn these terms, right? Okay, now I separate the things. Tangent line. We need to understand what is tangent line and rate of change, right? So in the calculus, the main task is actually this, right? Because using the limits, we can discuss the tangent, and again another application is rate of change. Then later we can discuss the velocity also. So both are same, but application is different. So that's why we can see these terms. But this is very simple concept. Let's take actually we learned this one at the beginning, right? Using limits, find slope of the tangent line to a curve at a point, right? we know that whatever we have learned, we learn the limits. Using that limits, actually we can find the tangent line, right? Slope of the tangent line at a point. That is why we learn the limits actually, right? Now, you may remember that I draw some graph and took the 2 points called P and Q, and little by little I bring the Q point very, very near to the P point. Actually, not exactly, but really, really, really very close to the point P. So the same thing we are going to do here, but in a different representation. Because now we are talking about the different terms, tangent line and O rate of change, but the theory is same, right? So let's take a graph curve. Take 2 points. So if I define the same way, this is P, this is Q, because I use the same letters at the beginning. So using this is a secant, right? The curve is secant. So using these 2 points, actually, if you need to draw a line, you should have 2 points. So I use these 2 points and draw the line. Need to shift. Let's draw it again. Right. This is the line. So if you need to find the slope of this line, so you can find it using these 2 points, right? That's the actual thing. But the thing is, you have to find the slope of the tangent line at a point. So point is P. I define a point called P. But I here define another point as Q. Then I will bring that Q point really, really very near to the P. So what's happened here? So let's define the values for this. This is x naught. And here, not like the previous case, I will write the different here called h. Then if this one is x naught and the difference is h, then you can write down this value is x naught plus h. That's the way of representing this point, right? Now the function, this function is fx. So you can find out this value. So what is the value of point x naught? This should be fx naught. And the point x naught plus h, the value is, we can write x naught plus h. Okay, now I am using the knowledge you have learned at the O level, right? If someone give you to find out the slope, right? So how you do? Normally, you find out the difference of y value, then divide it difference of x value, delta y over delta x. Right? So in here, you can write the delta value is this way. delta value means, delta y value means here. From here to here is the difference. So how to write the difference? F x naught plus h minus f x naught divided by delta x. So delta x difference is x naught plus h minus x. So here you can represent it as h. Okay, this is the slope of this line, but this is not the tangent line, right? This is not this tangent line. Okay, we can call this is a slope of secant, whatever seen on this view, right? So I will write the letter m. This is m for the secant, right? Secant line. Okay, then what we have to do to get the tangent? What you have to do? You have to make q. Need to bring to p, right? So how to do it? How did you bring this q point really close to the p? How to do? How will you do? So only thing is what? You have to minimize the h. You have to minimize the h. You can see you minimize the h little by little. You can see your q points really close to the p. So little by little it comes to or approach to t. So what is the level of minimizing h? You need to bring the h really close to the zero. H approach to zero. Right? Then this q point really close to the p. So by talking this one, these terms really close to C or h approach to zero means you have to use the limits you have learned earlier. So you are approaching this h to zero means you are taking the limits. Right? So let's take the limit of this slope function. Then this is a tangent of, a slope of secant. So if you need to take the tangent at the point P, right? That means m tangent. Right? What you have to do, take the limits of this f x naught plus h minus f x divided by h when h approach to zero. So this is the things you have to do. Now, this is not the secant or tangent of the secant line. This is actually what? The tangent, the slope of the tangent at the point P. Right? Because you bring the h value to C approach to the zero. Okay. So if you need to find the tangent at a given point, what you have to do, you can use these things. Right? First define 2 points, then bring the difference, having the h difference, then bring the h approach to zero. Then you have a answer. That answer should be the slope of the tangent at that point. Okay. For example, find the equation actually no, we are not going to assign the h value to the 0. Here we are taking the limits, right? We cannot apply or substitute the 0 for h here. That is why we are talking about the limits. We did not apply or substitute the 0, right? We are taking the limits. So taking the limits, now you already know how to find the limits of any function. In here, your function is there. So you have to bring the h approach to 0, not the 0. If you bring the h into the 0 means, or substitute 0 means, you bring the q point onto p. So you don't have 2 points. If you don't have 2 points, you can't find the actually draw a line or find out a slope, because if you find the slope, you have 2 points. Here in the limits, we did not discuss the h equal to 0. Here what we have do, we minimizing the h very, very, very near to the 0, right? So example, find equation of the tangent tangent line 2y equal x squared at, let's take the point 0, 1. This is the point. But not 0, 1, let's take 1, 1. Right? So this is the x value, right? This is a point, defined point. So we consider this one. How to do this? So your function is, let's write down the function as this way, fx equal x squared. So your equation is what? I'll write down it here again. Tan limit of when h approach to 0, fx naught plus h minus fx naught divided by h. Right? Okay, let's first find out the x naught plus h. Here x naught means 1. This is x naught. 1 plus h. So that is 1 plus h. Yeah. Okay, next one is you need to find the fx naught. Fx naught means f1. F1 means 1, right? Now you can apply it. Limit of h goes to 0 as h approach to 0. Fx naught plus h means 1 plus h squared. Let's celebrate it. 1 plus 2h plus h squared minus fx naught is 1 divided by h. Right. Now you have this goes, then you have like scaling when x approaches 0, can just take out the h from this remains, then we have 2 plus h divided by h. So here h is not equal to 0, right? If it goes to 0, we cannot do this, but we approaching h to the 0. So you can divide it. You can remove this, then you have limit of h goes to 0, 2 plus h. So at this moment, so this one is like a polynomial, so you can directly apply it here and find out the limit that is equal to 2. So the answer, here the problem asks the equation, right? Find the equation of the tangent line. So this gives the slope of the tangent line. So if you have the slope, then you can write down the equation very simply. How did you find an equation of a line if you know the tangent? That is, you have to use this one. Y minus y1 is equal to m times x minus x1. So y1 and x1 is a known value. For see here, you have this, right? Y value and x value. So apply it here. Y minus 1 equal to m means 2. X minus x1 again here 1. So you can solve this. 2x minus 2 here negative 1. It comes to this end positive 1 y equal to x minus 1, right? So this is the answer for this equation. So equation of the tangent line is here. So this is the slope of the tangent line. If you come to this point, then you can write down the equation of the tangent line. Right, do this example. Find the equation of the tangent line to y equal 3 over x at the point 3, 1. Right? You can do it later at home, right? Then do this example. Find the slope of tan line to y equal root x at any point. Here you have some different case. Earlier you have a point. Now they ask the slope the of the tangent line at any point. Right? So this one you can do, right? So what is the happening there? So earlier you learn how to find the limits in the different cases, and you practice to find the limits. Now, whatever you have learned, now you apply that knowledge into practical application. So here you can find the tangent line, you can find the slope, then you can find the tangent line. To finding slope is the limits part. So here you are applying the things of limits in the practical cases. So in here you have a different one. Find the slope of the tangent line to this function at any point, right? Not a given point, at any point. So in here you should have an equation for the slope also, because it does not give us, they did not give us the point, so we have to represent it as an equation. So let's do this one. Let's first write down the equation of the tangent line. Okay. What is the f x naught plus h? That is square root of. I will now generally I will write x naught as x plus h. Then f x naught means root x limit of x at h approaches 0 root x plus h minus root x divided by h. Right. Now this is the limit function. This is application. At this point, this problem sees as application. Right? But at this point, now it is a mathematical problem. Right? So if you master to solve the mathematical problems, so application is nothing. Right? Okay. Now at this point, you solve these kind of limits, right? These kind of problems. So here you have something square root of here minus square root of there. So what is the next point to solve this one? What you can do? Because at this space you cannot solve this. So you have to take action to simplify this. What is the things you have to do? මොකක්ද මේ ලයි කරන්න පුළුවන් බලන්න. බලන්න ප්‍රතිපදයෙන් වැඩි කරන්න පුළුවන් නේ conjugate. So let's multiply this. here the solution simplification is x plus h minus x. So it removes the x part, so h is there. At the bottom, now h, so x plus h plus root x. So you can remove this h, right? Because h is not equal to 0. So then you can write limit h approach to 0, 1 over square root x plus h plus x, right? Then you can solve this. This is equal to h equal to 0 means root x plus root x, that means 2 root x. Right? This is the m tan. Right? So find the slope of the tan line to y equal root x at any point. So this is the answer point. But think if you have to find the tangent line at the point 1, 0 like that, then you can apply 1 to there. Then answer is half. Or someone said he need to find the slope at 4, 1, then apply 4 there. Then answer is 1, 2, 4 means 2, 1 over 4. Like that, you can find the slope at the points, any points. So this is the equation type. So equation for the slope. So if you know the equation, you can find the slope at any point. Okay, again, now I'm going to another application. But you have at the title begin. Average velocity. Now we are going to talk about the velocity. Right? Because you know that title, there is a velocity part. So first we understand the velocity, average velocity. What is the average? So at the O level you done. So දුර වැදීම කාලය. Right? ඒ තමයි average velocity. මධ්‍යන වේගය. Displacement divided by what? Time. Okay, then now we are going to see this problem in advanced way, right? That is the difference. So this is the application. So think we have a function that gives us a displacement at a time. Let's consider a function called like this ft. This ft function gives us this displacement, right, at a given time, right? So now we use the same theorem or same way we learned earlier. What we have to do, we define a time period called h, right? Delta t called h. I use the same letter what we did use earlier, and write down the average velocity, right? So this is the function. You have a function, right? Same thing, right? ft. This gives us the distance. So at the beginning you can write a t naught there, and later difference is h. So this one is t naught plus h. So you can find out f t naught, the displacement at the t naught, and you can find the displacement at the t naught plus h here. So what is the average velocity? Average velocity means displacement over time, right? Displacement over time. So f t naught plus h minus f t naught over h. Right? This is the average velocity. So what you did here, you have a very simple question. Now you see that question or application in a different way. Now you see, earlier you don't know this one, but now you see the change of displacement with the time. We call that as a function, right? Then we will see the average velocity using the displacement over time. So displacement is ft plus h, which is little bit distance or different of the time. So ft naught plus h minus ft, the displacement, and time is this difference of, so it's called h. So that's the thing. So let's take very simple example. Find and average, find the average velocity of, this is the function. Let's take this a displacement function. So it's better represent it as s. St equal 1 plus 3t minus 2t squared. Right. This is the function. You have to find the average velocity on this range. That is 1, 3. Right. This is the time interval that you have to consider. Within this time period, you have to find the average velocity. So what is the time difference? You can write down h value for this. That is equal to what? 3 minus 2. 3 minus 1. The difference is 2. Okay. Okay. Then let's apply average velocity. So s t naught plus h. That means what? Here 3, here 1. T naught plus h means actually is 3, right? Minus t naught means s1 over h means 2. Okay. S3. Can you simplify this? 1 plus 3 times 3 minus 2 to the power 3 square minus 1 means 1 plus 3 minus 2 by 2. What is the answer? Please solve this. Yeah, you need to bring the bracket here. Otherwise, you may have different answer. Then 3 minus 2, 1 minus 1. So tell me the answer. Sustainable. This will run by
minus 1.495.
numerical marker is taken. Divided by 2. Yes, it is 5. Negative 5. Now you got the correct answer. Right. Anyhow, around you can feel that this is average velocity because you find the two different points. Considerable. There are considerable distance in between 2 points. Right. So you find the average velocity. Right. So this is your well-known one. Right. Now you are going to something advanced. What is that? Someone said to find that this instantaneous velocity. The point එක තියෙන ප්‍රවේගය. So now you know how to find the average velocity. That is ft plus h minus ft naught divided by h. Right. Okay. Well, now what do you have to do? If someone said find the instantaneous velocity at this is t plus h, what do you have to do? Same thing. This is the limits. How to handle the limits. So this application. So you need to bring that point. This is P, this is Q, very near to P. So you need to, if someone said, please find the velocity at T naught, then what you have to do? That means you are finding a tangent. Right? You are finding a tangent at that point. That's the velocity at that point. Earlier you have average velocity, but if you bring this h very close to 0, that means you are finding the instantaneous velocity. So what you have to do, you need to take the limits, right? Limits of this equation, same equation. So if you need to find the instantaneous velocity, what we have to do is take the limits, bring the h approach to 0. Right? So now this is at pure level, this is at O level, this is at university level. Right? You are doing limits. That's the difference. So, for example, I will give you example. Tell me the answer. You have an equation for displacement called ST that is equal to 500 minus 60 t square. Right? Problem is find the v instantaneous velocity at 5 seconds. That means t not equal to 5. Can you do that? Right. You have to take the limits when x approaches 0, t naught plus h. So here is f t naught plus h. F t naught plus h. What is that? 500 minus 16 t plus h squared. F t naught, that is 500 minus 16 t naught squared. Then divide by h. So this I delete this one. Five hundred. When you expand this, the t naught squared multiplied by 16 t squared, then middle part is 2 t naught h means 50. Negative 16. I will multiply all the terms from the negative 16. Then negative 2 t naught is 32. T h negative 16 h squared. Here negative 15 plus 16 h. Then here you have h and 16 for the common factors. Yes, your answer is correct. And we can take 16h to the out. Then we have 2 t plus h divided by h. So you can cancel out h here. Then you need to find the limit because you can write for substitution. Then this one will become to 16 times 2t, 32t. So they asked to find at 5. So 32 times 5 is that. Is the answer. Instantaneous velocity. Okay, now the same question. Can you do this? Same question, but the problem is now like this way. Find the instantaneous velocity. Right? Find the instantaneous velocity at any point. That means you should have give me an equation. Can you do that? Okay, do this one as well. Right? So you can should have an equation for this. Right? Next title we have to talk about rate of change. Actually, the term is different, but you know what is the rate of change means again what? Actually slope. Right? This slope is the rate of change. Rate of change is again y difference divided by x difference. Right? That's the rate of change. So the term called something related to application part, but inside what is here? Again, whatever you have learned earlier, it is the slope. So if you have a function, you can find out the slope, if it is average or if it is instantaneous, whatever you can do anything. Slope is a rate of change. Let's take a example, not example, a function called f minus x plus 1. Then here represent the slope. Whatever in front of x is the m, related to m. So this is in this equation. So y equal mx plus c, no, in the general way. So m represent here slope. So according to this one, this is equal to minus 1. We take another example, y equal 3x minus 1. Then this is the m part. M is equal to 3. So this is the rate of change actually. So if someone asks again, instantaneous, rate of change, that is the same thing you have done, the slope at a curve at a point. Right? If someone asks instantaneous, means they ask about the rate of change at a point. So what you have to do again, you have to use the limits, bring this next adjacent point very, very near to the first point. That means calling about the limits and find the instantaneous slope. That slope is the instantaneous rate of change. So nothing, any new thing. Only thing is the application coming from the outside, they called another term. But you have to do the same what you did earlier. So you can write down the equation for the rate of change in this way. If I interpret this term in R, so rate of change as average form, you can write down this f x naught plus h minus f x naught divided by h is the average form. If someone asks rate of change as instantaneously, then R equal limit of nx h approach to 0 f x naught plus h minus f x naught divided by h. So these are very same what you did earlier, right? But we are describing different application. Here rate of change, earlier velocity, earlier tangent, but happening is same. Application is different. That is all. Right? So let's take example. Find the average and instantaneous rate of change of this the function fx 3 squared minus 4. This is the range 2, 5. This is for average. This is for instantaneous. Can take point negative. So please complete this one at the home, right? Apply to these points, find out average, then apply this point into here and take the limits for the instantaneous rate, right? So I hope you can understand the application, how we apply the limits in the environmental applications, right? So whatever you have learned at the very low level, now we can see same things in something advanced version, right? That is the tricks behind the calculus, right? So we have to learn something more, right? So inside the limits, we can see we can apply this limit in the several applications. So that is the things you have learned today, right? So then I will close the session today, right? So I will upload the previous videos and as well as today ones also. So please, if you miss some part, you can go through it and capture the missing part, right? So then thank you very much for joining today, right? Okay.
Thank you, sir.
Recording stopped.